Next, we can see that electric field is conservative. That means if you're finding the closed line integral of E along a closed path, that must be 0. So that's called electric field is conservative. Or we can see what is the relation between E and V. So for that, we are taking a path A to B. Then we are going to find what is the potential from A to B and what is the potential from B to A. So the potential difference between point A and B is independent of the path taken. That means if you are finding VAB, then that should be equal to minus of VBA. So we can find what is VAB using the expression VAB is equal to negative line integral of BA to B E dot EL. So similarly, what is VBA? VBA is negative line integral of B to A E dot EL. So from this equation 1, that means VAB equal to minus VBA, we can write it as VAB plus VBA equal to 0. So we can replace VAB as minus of A to B E dot DL plus VBA as minus of B to A E dot DL. So we can take this minus outside. So that becomes minus of A to B E dot DL plus B to A E dot DL. So we can see that if you are finding A to B then B to A, we can see that the line is completed. That means the path become closed path. So we can write this as negative of closed line integral of E dot DL is equal to 0. If we are taking that E to RHS side, we can say that the closed line integral of E dot DL equal to 0. So that is the condition for electric field is conservative. That means the line integral of E along a closed path must be 0. So physically it means that no net work is done in moving a charge along a closed path in an electrostatic field. So if you are moving a charge on a closed path, then physically there is no net work. So that is called electric field is conservative. So we can apply the Stokes theorem to equation 1. So according to Stokes theorem, the line integral of a vector along a closed path is equal to the curl of surface integral of curl of that vector. So we can write it as line integral of E dot dl equal to surface integral of curl of that vector, surface integral of del cross E ds. So that should be equal to 0 from first equation, or we can say that del cross E equal to 0. So this equation 1 and this equation 2 are known as Maxwell's equation for static electric field. Equation 1 is known as the integral form of Maxwell's equation, and equation 2 is known as Maxwell's equation of point form. This is for the equation in static electric field. So and this equation also represent the conservative nature of an electric field. So the relation between E and V is that E is equal to minus del V. That means the electric field intensity is the gradient of potential. So that is the relation between E and V. So remember that the electric field intensity is the negative gradient of potential. So the negative sign shows that the direction of E is opposite to the direction of in which V increases. So their directions are opposite, that's why negative. So remember that the electric field intensity is the negative gradient of potential. So that is the relation between E and V. So in next video we can see what is magnetic flux density.